have to do that.
Welcome to another episode of UEN's PDTV. In this episode, we're going to try to make sense of sense-making. Laura Gibbons is a member of our UEN PD team. She has taught for years as a science and STEM educator and understands firsthand how important sense-making is to transformational student learning. Laura, thank you for joining us on PDTV.
Thank you. It's good to be here.
Will you just explain to us what you mean by sense-making in the classroom?
At the heart of sense-making, it is being able to understand anything. And in the science classroom, that usually is broken down into three different parts. First, we talk about disciplinary core ideas. There are certain things that we want our science students to know and understand. We call those their core ideas. And you can find those in state standards or next generation science standards, but those are central to students' learning. The next thing that we really want with students making sense is we want them to be able to layer that learning. And so there's another portion called cross-cutting concepts. And that's cause and effect. That's the students being able to take something and maybe go one layer deeper with it. So the third part of sense-making within the science classroom is being able to apply science and engineering practices. And that in large part will deal with teachers using students' investigative process. They'll be given a problem and trying to figure out how it is that they address that problem. They're asking questions, they're making observations, and then along the path, they're adjusting what they think may happen. And then gathering data. I cannot underestimate the importance of good fundamental data in our students' learning. And so those processes are also interwoven into the whole sense-making experience.
We're actually going to observe some teaching, some great teachers that you recommended to us, starting with a STEM and science teacher. Can you tell us who are we about to observe and what should we be looking for in her teaching?
Today we're going to see JoAnne Brown at Olympus Junior High in Holiday, Utah. So things that we will see with JoAnne's techniques is we're going to see her guiding. But at the heart of the experience, we should see the students. We should see the students conducting the research. We should see students asking questions. And the teacher really being a facilitator of that experience.
I've taught here at Olympus Junior High for 27 years. It's a suburban school, pretty upper middle class, although we have kids from all walks of life.
Tell us a little bit about what we're going to see in your lesson and specifically what sense-making techniques are you going to use throughout your lessons?
I teach a whole variety of classes, and so you're going to see three different things that are very different but all hands-on and student-centered. So for my gifted 7th grade class, they are working on a project called Genius Hour. So Genius Hour was invented by Google, and the idea is to spend 20% of your time working on a project that you are passionate about, that you pick what you're doing. And so I do need to tie it to our standards, and so I open it up to them and say, here's our standards, what are you gonna do? And so the students will design their own projects, and they're early on in the process. So they're designing their own projects that will show their learning of that standard. No, it can't be in Minecraft. It needs to be like a separate paper thing somebody can have next to them, like a tour guide, okay? So like they check, like a little passport where they check it off and go to different parts. Okay, so yeah, just hold on. So just make that. I need something more visible instead of I have to take an hour and a half to tour your Minecraft world to find out what you did. Okay. Yes, that's what okay, see this, Jensen? So they've done a little slideshow that's kind of a tour of what, so then on each of those slides you would explain, here's what you're seeing as you go past here. Yeah, that looks great. I have lots of little solar panels that are about that size. I probably have a couple dozen, so, and they really work. So you're welcome to use that for your model.
Of putting them on top of the snow cats too, to make them.
That sounds solar snow cats. Well, and that's the thing is, yeah, it's stormy once in a while, but I mean, I can't think of a better place for solar than white snow and. Yeah, exactly. My second period is STEM Concepts, which is actually a CTE class. And so the standards aren't nearly as specific. And so we are taking them through the acronym STEM. And we have just started engineering. And so for engineering, I am having them become mechanical engineers and make what's called a scribblebot. They just basically get a motor and a cup and some pens, and they have to make it draw. And I'm specific to give them objectives to go through or prizes that they can win. Best drawing, fastest, beauty contest. And the hope is with a variety of objectives like that, it will hit everybody's interests, but also make it so they don't feel like a failure just because it's not the fastest. So you've seen the materials. Once you have an idea that you think might work, you're going to show it to me for approval before you get any supplies. Then you can start putting stuff together, creating and testing. You'll most likely have to go through the engineering design process several times to improve your design. I've told them that engineering is learning how to fail with style, but it's also about eventually succeeding in what you want to get. So that's what you'll see in STEM. Those early struggles with, oh, what do I want to do? All right. Oh, I like it. That's markers. I haven't seen this. Okay, hold on and I'll get you the stuff. Then my third period class is 6th grade honors, and we have just decided to enter Clark Planetarium's Cosmic Creator Contest. We have already finished our unit on astronomy, and so they are doing this as their final assessment. So they're doing a big project and putting it into a website they designed that's their portfolio, and they're going to choose a topic and showcase what they know in that topic from the 6th grade astronomy standards. What form are you going to focus on? What format? So are you looking at video or animation? Are you just going to draw something? Maybe you'll do some sort of puzzle. And then maybe you're going to make a 3D model. And then the approaches are the specifics of what exactly are you going to do. My role is as a facilitator and a supporter. I get them what they need. I help them to understand what they need, because sometimes that's the hardest part, is figuring out, I don't even know where to start. I try to give them specific objectives and specific requirements. I give them rubrics because they do need to work within a framework. I make it structured enough that they know what to do and then step back and let them do it in their own way. To me, this is what proficiency-based learning is it's not so much taking test after test until you pass it, it's actually digging deeper in your own way to get to the root of what you understand about that concept.
Now, sense-making doesn't just happen in the seed classroom. It can happen in any content area. Who are we observing next, and what should we be looking for in this teaching sample?
Next, we will be observing Nicole Belnap, and she is at Tooele High School in Tooele, Utah. What we'll see from her is an innovative way to teach and instruct students with math. We should see her asking questions, but also similar to JoAnne, traveling around, because remember, with sense making, the student is at the center of the experience. They have to be the ones driving that learning experience. We really want them to be invested. We won't necessarily see the teacher directing a lecture, but what we will see is that she will ask questions, and that then from those questions can challenge her students.
So tell us about the lesson we're about to watch and what techniques you use to engage students in sense-making.
One of the techniques that you need is small groups, where the students themselves are driving the conversation. They're wondering how they get to the conclusion. So instead of me telling them the conclusion, I'll oftentimes lead them there. X marks the spot. Here's where you're going. But then I let them go on the treasure map, they go on the path, they figure out, and then they come to it, and when they dig it up, oh, even though I've kind of already sometimes shown them where they're going to go. Once they get to it, that's the aha moment. The sense-making happens when the students themselves are solving the problems, when the students themselves are given a task and they're going from one to the other. So what the students were doing were creating an equation, knowing that they were vested. Now what happens to this equation? Can I solve it? And I gave them the parameters. And I think in sense-making, the part the teacher has to do behind the scenes is you have to create the parameters for the students. Otherwise, you don't get them to make sense of anything. They're stuck in the details. They're stuck on the sidelines. Put them in the game, give them the game plan, and then let them play.
I love that analogy you gave of, giving them the parameters of the game, putting them in the game and letting them play, and that your role as the teacher is to coach them along and give them the hints and the clues that they need to be successful in that game. You're not the only part in that, though. They were also working in collaborative groups and things like that. What role does that play?
You have to trust your team member. And sometimes you get to pick who's in the game with you, and that's great, and you know how they work. And sometimes you don't know who you're with. So your part in a group is to trust that the other people are working and to be open to their ideas. I think as a teacher, you have to know what will be effective. Give them something to warm them up to be successful. And then let them be uncomfortable. Let them embrace the opportunity to be wrong. And you as a teacher, be there to celebrate that that's a learning opportunity. But we're teaching with the students, and there is no one size fits all. That's the thing. Even in sense-making, there's no one size fits all. And part of it is, to be a successful teacher, I think, is to understand your content. You have to know it better than your students. You have to be willing to put the time in to understand what questions they might have and foresee that, and then help them make sense of those questions.
That's it. Break it up. This is f of x. That's g of x. You have to do that.
Thank you so much for letting us visit your class today and talk to you about your process. Now that you have seen sense-making and PCBL strategies in action, consider how you can implement these teaching practices in your classroom as well. Start by understanding and knowing your core standards. Then be sure that all the projects and learning activities that you do tie back to those core standards. Then you can implement some of the strategies that we've seen in these demonstrations. Remember that it doesn't matter what content area you teach, whether you teach science and mathematics or English language arts or music, you can still engage students in sense-making by asking questions and allowing them to explore their questions. Provide instruction to your students in a variety of ways as well. Give them opportunities to read, write, speak, and listen surrounding the topics so that they hear it multiple times and they experience it in different ways to really make sense of what's being taught. There are a variety of technology tools that can support your teaching and student sense-making. For example, you can utilize Canvas to provide materials and information to your students. You can also utilize things like Google Sites and Google Docs and Nearpod presentations. Students can also conduct research with the assistance of technology tools. For example, Utah's online school library has huge databases where students can look up the concepts that they're exploring and making sense of. For even more ideas, strategies, and tools to help you master these competencies, be sure to visit uen.org/PDTV and access the teacher toolkit that accompanies this episode. Thanks for watching UEN's PDTV. To access additional professional development resources from UEN and to schedule a training, be sure to visit uen.org/development. We'll see you next time.